Welcome to College Algebra. In this lecture video, we're going to continue with our lecture video series of 4.5. In this objective, I want to show you how to graph rational functions by hand a little bit, and then we will do an example from the homework online, just to kind of incorporate how you do it by hand versus how you do it in the calculator, how they incorporate together. Alright, so here are the following steps on how to graph rational function by hand. So what we want to do, okay, step number one, determine the symmetry, the even and odd function. We can determine the symmetry at the end of the problem when we find the points. So what we want to do when we graph rational function is make sure we know how to find the y-intercept, the x-intercept, also called the critical points. We need to find the vertical and the horizontal asymptotes, and once we've done that, then we can begin to sketch, okay, our graphs based on what we already found. All right, so I will show you how to do step number 6 after we begin to sketch our graph. Okay, so first thing, find the y-intercept. So remember now, y-intercept is find y when x is equal to 0. Alright, so x equal to 0 right here. So if I substitute 0 for x right here, that will be 7 over negative 9. That will be negative 7 over 9. You know what? I'm just going to go right now. Negative 7 over 9. Alright, how do I find x-intercept? How do I find x-intercept? Normally, the idea of finding x-intercept is find x when the y equal to 0. So f of x is the y, so this will be 0. So we will say 0 equals 7 over x minus 9. So when we write it out like this, one of the trick we can use is using the idea of proportion. So we will treat the 0 as 0 over 1, and we'll perform our cross product. 7 times 1 is 7. Set it equal to 0 times these two terms down here. So if you think about it though, 0 times x is 0, 0 times negative 9 is 0. So when I do my cross product here, 7 equal to 0, which we know 7 cannot equal to 0, so that tells me that I don't have any x-intercept. Okay, 7 cannot equal to 0, so in this particular problem, I don't have any x-intercept. Alright, let's find the vertical asymptote. So last time, if we recall the steps on how to find vertical asymptotes, we were supposed to factor, reduce, then we set each factor in the denominator equal to 0, solve for the variable. So there is nothing to factor for the top and the bottom. So for our vertical asymptote, we can just set the denominator equal to 0. Let me just copy and paste it right here. This is my function. Set denominator equal to 0. There's nothing can be reduced and cancelled. So if I set my x minus 9 equal to 0, x will equal to 9. So that's my vertical asymptote. Alright, for the horizontal asymptote. Okay, let's take a look at horizontal asymptote. Got 3 different scenarios. When the degree of the numerator are the same, when the degree of numerator is less than denominator, and the numerator greater than the denominator. So those 3 scenarios. So if I look at my function right now, the degree of numerator is actually 0. Degree of denominator is 1. So the numerator is less than the denominator. So that means the x-axis, or y equal to 0, will be my horizontal asymptote. So think about this now. Think about this. If my horizontal asymptote is the same as the x-axis, and I don't have any x-intercept at the same time, so that means my graph will never cross over my horizontal asymptote. Because horizontal asymptote is the same as x-axis, since I don't have any x-intercept, my graph will never cross over the horizontal asymptote either. Okay, so with all these things being found so far, we can begin to sketch our x and y axis. Okay, I'm going to sketch it for you so I can explain to you what's going on. Okay, alrighty. So let's see what we got so far. We got y-intercept 0, -7/9, so that's a little bit below. Okay, that's a little bit below the. That's a little bit below the origin. I'm gonna put it right here. X-intercept don't have none. Okay. Vertical asymptote occur at x equal to 7. So 1, 2, 3, 4, 5, 6, 7. You know, something about it's about right here somewhere. Okay. I'm gonna do red. So this is my vertical asymptote, and I also have a horizontal asymptote is my x-axis. I'm just going to establish this graph real quick. Use blue. Okay, so here's my horizontal asymptote. Alright, so find the points above or below the x-intercepts and the horizontal asymptotes. Find the point to the right, left, and between the vertical asymptote. So what does that step number 6 here is trying to say is this. I got one vertical asymptote, so that separated my graph into two parts, left and the right. Okay. So here are your choices. Okay. To the right or to the left of a vertical asymptote, I can choose a graph look like this, go this way, or this way. So these 4 choices, okay, these 4 choices are for to the right and left of a vertical asymptote. Alright, so 1, 2, 3, or 4. Okay. So let's think about this. Let's do it to the left. To the left of my vertical asymptote. Remember, there is a intercept right here. Okay. There's a y-intercept right here. So imagine this. Imagine if I choose number 1 and draw my picture this way. Why this cannot be my choice? Why this cannot be my choice? Because I cross over the x-axis when I don't have any x-intercept. So cannot choose that. Number 2, can I choose something like this? No, cannot choose something like that because we mentioned that your graph can never cross over the vertical asymptote. Plus, in that direction, I'm also going to have another y-intercept. Okay, number 4, cannot choose number 4 because it will still run into what? It will still run into the whole vertical asymptote. So my choice got to be number 3. So my graph will look something like this. And at the same time, I know I cannot cross over the horizontal asymptote or the x-intercept. So my graph is kind of forced to be look something like this. Okay, so when we do step number 6, it will help me determine which one is my choice. So imagine if I would pick a number to the left side of my vertical asymptote that says x equal to 7. If I would pick a number to the left, let's pick 6. Okay? If I pick 6, 7 over 6 minus 9. That will be negative 7 over 3. And being negative telling me that it's actually below the x-axis. So that's why this is an appropriate choice. Alright, let's think about this, okay? Pick a number to the right-hand side of my vertical asymptote. That will help me determine which choices I will make as well. So why don't I just pick 8? 7 over 8 minus 9. Which again is negative 7 over 1. It's actually negative 7. So negative 7 for y value, in a way, kind of forced me to choose number 4. But when I choose number 4, I got to draw it where it does not cross over what? Does not cross over the x-axis or the horizontal asymptote. There you go. Alright. So that's how we sketch the graph. Okay, very roughly. Let's try another one. Okay, same thing. Y-intercept. So remember on my previous problem, that the left side of the vertical asymptote got to go over the y-intercept. Y-intercept. Find y when x equal to 0. So if I plug in 0 here, 0 squared is 0, 0 minus 9 is negative 9, so that would be negative 1 over 9. Alright. X-intercept. X-intercept. Find x when the y equal to 0. Alright, so y equal to 0. So 0 equals 1 over x squared minus 9. So if I use the same trick using what? Using cross product. Okay. Remember, x-intercept is what's on the x-axis. On the x-axis, y values are 0. So that's why we set my function equal to the 0. Alright, so if I do a cross product again, this time it's going to give me 1 equal to 0, which I know that's absurd. That cannot happen. So that tells me again, when that, when this cannot equal to each other, that tell me that I don't have any, okay, x-intercept. Alright, vertical asymptote. Set my factor. So if I factor this thing, okay, if I factor this, that would just be 1 over x plus 3 times x minus 3. Since the numerator and denominator cannot cancel out, I will set each factor equal to 0. So that will tell me my vertical asymptote, x equal to negative 3 and x equal to positive 3. So I have 2 vertical asymptotes that's going to divide my function into 3 different parts. Alright. Horizontal asymptote. This time the degree of the numerator is 0 again, x to the 0 power, which is less than x squared down here. So again, the y-axis, the y equal to 0 over the x-axis will be my horizontal asymptote. Alright, so let's sketch it. Oh, by the way, when we're talking about the word symmetry here, I pick 1 point to the right, 1 point to the left of my vertical asymptote. See how different the 2 answers are? So that's why at that particular point, this actually doesn't show any symmetry. We can show symmetry when we actually graph this thing in the graphing calculator. Now I will mention it in a minute when we begin to do this on the graphing calculator and on the homework. But right now, I just want to show you how we sketch this stuff by hand, so that everything will actually make sense. So let's take a look. Okay, let's take a look. I'm gonna move around these pictures here. Okay, so fit. So this time, so again, my y-intercept is a little bit right below, okay, the origin. Don't have any x-intercept. Vertical asymptote, two of them, one at 3 and the other one at -3. 1, 2, 3, something like that. Let me relabel it real quick for you. So remember now, when we graph on the calculator, the vertical asymptote is something we do not see. That's why I have to previously identify it. Alright, I got my horizontal asymptote in place. I got my y-intercept in place. So everything is good to go. Now let's think about this. Now I got 3 parts. These choices right here is for the left and the right of my vertical asymptote. Alright, and I will write one out for in between the 2 vertical asymptotes as well. So to the left of x equal to -3. I cannot pick 2 because 2 goes straight into the vertical asymptote. Cannot pick 4, it goes straight into it. So now the choice is boiled down to, do I do the first one or do I draw the third one? And that's where finding points comes in. So if I pick -4 for x and substitute into my function 1 over x squared, that'll be -4 whole thing squared. Alright, -9. That's going to be 1 over. Let me do it a little bit. Let me move this a little bit down, okay? That'll be 1 over -4 whole thing squared is 16. 16 minus 9. What's 16 minus 9? 7? That's 1 over 7. And that's positive. Positive means above the x-axis. Therefore, I have to choose number 1. And I will draw it where it does not what? Cross over the horizontal asymptote or the x-axis. Because I don't have any x-intercept. And it turns out my horizontal asymptote is the x-axis. So I cannot cross either. Alright, to the right hand side of the other vertical asymptote. So since I just plug in a -4, now I'm going to plug in a +4. Pick a number to the right hand side of that vertical asymptote. So that will be 1 over 4 squared minus 9. So again, 4 squared is positive 16. Positive 16 minus 9, which is positive 7. So again, this number, this y value is a positive, so that forced me to choose number 2. You know, because I can't choose 1 and 3, drawing it where it runs straight into the vertical asymptote. So my choices here is either 2 or 4. So it turns out the y value tells me to pick number 2, because the y value is a positive y value, so I have to kind of stay above the x-axis. Okay. Now, as far as the in between the 2 vertical asymptote, your choices are, okay, your choices are a U looking thing upward, downward. So these look like those polynomial function almost. Number 3, your another third choice. Is something look like this, and another choice can look something like this. Okay. So which one can you pick? Just using logic, can you pick number 1? Can I pick number 1, a U point upward? No, I cannot, because they actually cross over the x-axis twice. Can I pick number 3? Where I come over here, connect with my y-intercept, and go down. Nope. Cross over the x-axis. I don't have any x-intercept, so I cannot cross over the x-axis. Same thing coming from the other direction. That's not going to work. Cross over x-axis again. So the only choice I can make here is number 2, where I can draw it and cross over the y-intercept and stay what? Right below. So my graph is approximately look something like this for this particular problem. Okay. All right. One more example. All right. This one's a little bit of work. All right. Y-intercept. If I will plug in 0 for x in every single x I see, 0, 0, 0, 0, then I'll be negative 21 over negative 21, which will tell me the y value is going to be 1. So my y-intercept is at 0, 1. Alright, the x-intercept is a little bit different in this particular problem, because x-intercept means find x when y equal to 0. So f of x is 0 now. Set it equal to the x squared minus 3x minus 21 over x squared minus 4x minus 21. So if I use the same trick, 0 means 0 over 1. Do a little cross product. 1 times all 3 of these terms up here is still make them the same. So they'll still be x squared minus 3x minus 21. Find x when y equal to 0. Okay, it's finding x-intercept. Now when this 0 do a cross product, multiply these 3 terms down here, that will just be 0. So now when I'm solving for x, I'm solving a quadratic equation where I can actually factor this quickly. 21, that will be 3 times what? 7. That's not going to work. 3 times 7 is not going to give me 21. What times what is 21? No, I cannot factor this because there's nothing else multiplied together as 21. Oh, nope, this one cannot be factored. So now I got to use the square, using the quadratic formula. The bottom can be factored, not the top. Oh, what a shame. Alright, b is negative 3, so that'll be negative 3 plus minus square root of my b, whole thing squared, minus 4 times my a, which is 1, times my c, which is negative 21, whole thing over 2 times my a. Okay, let's see what this thing boils down to. It's negative 3, negative 1 times negative 3 is positive 3, plus minus. Let's see what's our inside the square root. Negative 3 whole thing squared, minus 4 times 1 times negative 21. Oh, 93, ugly. 93 is not a perfect square. And 93 is only made out of 3 and 31, so this cannot even be simplified even more, over 2. So basically what I'm looking at right now, alright, is 3 minus square root 93, see what that is, then divided by 2. So it's about negative 3.2 something. Excuse me, negative 3.32 something. Okay, keep this in mind, okay? The other one, I'm just gonna change my minus sign to a plus sign here, and then divide it by 2. 6.32 something. Alright, so as far as x-intercept concerned, my x is 3 minus square root of 93 over 2. And the other one, plus square root of 93 over 2 comma 0. Alright, so these are the exact value of my two x-intercepts. Okay, but I'm having decimal insert just to give me a guide on, you know, where I will actually cross over the x-axis just in a minute. Alright, so here is my function. Let's find some vertical asymptote here. So as you can recall, the top cannot be factored, but the bottom can be factored as using set 3 and 7. Okay, since the last term is negative, that means my inner and outer gotta be subtract. Since the last term is negative, my sign is one positive, one negative. To get a negative 4, I gotta have a negative 7 on the outer, positive 3 in the inner. So my two vertical asymptote, negative 3, and the other one is at x equal to 7. Alright. Horizontal asymptote. Here we go. Degree of the top and bottom are the same. Therefore, the leading coefficient will be my horizontal asymptote. 1 over 1 is 1. So I have a horizontal asymptote at 1. Alrighty. So based on what I found so far, let me bring these guys over. Alright, let's think about what I got so far. I have a y-intercept at 0, 1. So now this time go back up 1. Okay, y-intercept up here. I have an x-intercept about negative 3.2. So 1, 2, 3, 4. Let's say negative 4 is right here. I have an x-intercept about negative 3.2. That will be right here. The other one is 1, 2, 3, 4, 5, 6 point something. So that will be in between, somewhere in between 6 and 7. Okay. So I will cross over my x-axis at these 2 points. I'll use dark green. Dark green. Purple. Yeah, let's do purple. How about that? Okay. Alright. Vertical asymptote at negative 3. The other vertical asymptote at x equal to 7. 1, 2, 3, 4, 5, 6, 7. So this is right there. Ooh, this is a weird one. Okay, alright, let's see. To the left side of my vertical asymptote, which one do I pick? 1, 2, 3, 4. If I pick negative 4 in here. So let me copy this and paste it down here so I don't have to keep on scrolling up and down. If I plug in negative 4 into this function, alright, so that will be negative 4 whole thing squared minus 3 times negative 4 minus 21 over negative 4 whole thing squared minus 4 times negative 4 minus 21. So I'm going to use a calculator a little bit. Negative 4 whole thing squared is 16. Minus 3 times negative 4 is plus 12. Then minus 21. That gives me 7 on the top. Over. This is 16 plus 16. Minus 21. That's 11. And that's a positive value. Positive value here. Think about this. Positive value here. Alright, so that means at negative 4 is a positive value. So which one do I pick? Do I pick number 1? When I pick number 1, how can I draw it where it's going to cross over the x-axis and then go down? But I'm missing it because after I cross over x-axis, negative 4, the y value is positive. It's up here. It's not down there. Okay, so that means I got to do number 3 because I have to draw it where at negative 4 I'm still positive, but once I pass negative 4 I can begin to cross over the x-axis at my x-intercept. So you'll do something like this. Oh, by the way, remember now there was a y, there's a horizontal asymptote at negative 1 as well. So that's why this graph, as far as right now, staying underneath the y, stay underneath under the horizontal asymptote. Alright, but that still give us a, that still kind of raise a question. Will my graph cross the horizontal asymptote? Right? The graph will never cross over the vertical asymptote, but will it cross over the horizontal asymptote? Sometimes it can, sometimes it will not. But I gotta check it. The previous 2 problems we did, it did not cross it because, okay, because my horizontal asymptote was my x-axis, and because I don't have any x-intercept, my graph will never cross the horizontal asymptote. But this time, the horizontal asymptote is 1. So the way we do it is by setting the entire function. You set the whole function equal to the horizontal asymptote and see what the x value is when they cross over it. It's kind of nifty little trick. So if I say x squared minus 3x minus 21 over x squared minus 4x minus 21 and set it equal to the horizontal asymptote, and I can use the same trick as with the x-intercept, little cross product. These 1 times those 3 terms will be what's on the top over here. So that means I will get x squared, minus 3x minus 21 equal to 1 multiplied these 3 terms down here will still be x squared minus 4x minus 21. So now when the x squared are the same across from each other, they automatically cancels out. So that means I should end up with negative 3x minus 21. Oh, by the way, the negative 21 also canceled out. Ooh, that's nice. So now I just get negative 3x equal to negative 4x. So if I would move my negative 4x over, that will actually tell me x is equal to 0. Okay. Because there's nothing on this side. Let's move over. So that means I will cross over the horizontal asymptote when x equal to 0. And that's actually the same thing as my y-intercept. Think about this. Cross over the horizontal asymptote at x equal to 0. And that's actually my y-intercept 0, 1. That's the only time I will cross it. Okay, so that being said, let's do the right side of x equal to 7. I'm going to pick 8 this time. I'm going to pick 8. So in my calculator, I'm just going to type in 8 squared, right? Minus 3 times 8. Minus 21. Ooh. That's 19. Over. Alright, substitute 8 where the negative 4 is. So that's 8 squared minus 4 times 8 minus 21. That's 11. That's 19 over 11. That's also positive. Okay, that's also positive. So when x equal to 8 right here, the y value is positive. So that means for the right hand side of x equal to 7, I gotta pick number 2. Because if I would pick number 4, it will force me to start off from underneath the x-axis. So I will draw this picture this way. And I'm not going to cross over the horizontal asymptote because I only cross it right here. So now in between the two vertical asymptote, the only one I can choose got to be this one, number 3. Because number 3 will allow me to cross over the horizontal asymptote and the y-intercept. At the same time, it will allow me to cross over the x-intercept, the only other x-intercept I have. So my graph looks something like this. Okay. All right. So I'm going to do this particular example from the homework with you. Okay. So as I go over this particular problem, I'm going to type out the answer. Find the equation of vertical asymptote. Okay, so let's factor this bottom. So I'm going to go back and forth, okay? Vertical asymptote. 4 times what? 9, 5, excuse me, 6 and 9. 6 times 9 is 54. 6 plus 9 would be 15 in the middle. Alright, let's see if I can factor out the top. No, there's no way. 2 and 1 can never come up with a 10. Alright, so my vertical asymptote, x equal to negative 6 and x equal to negative 9. I got a 2 vertical asymptote. Selecting a button that will replace entering the end value. The value of the button is instead value associated with the separator. So I say x equals negative, what did I say? Negative 6, negative 9? Yeah. Comma, x equals negative 9. Okay, let's see if that's right. Yep, that's right. Alright, next step. Find the equation of the horizontal over the oblique asymptote or the slant asymptote. So the degrees are the same. Degrees are the same, so the leading coefficient 2 over 1, so that's y equal to 2. That's my horizontal asymptote. Okay, now I got vertical and horizontal asymptote. Now, here we go. Now identify the 4 order pairs on the graph of the function. Okay, they want you to do 4 order pairs. So here, I know what we can do here is actually go straight to the calculator. Okay, grab this function, go to the calculator, and find our coordinates. Okay, and I'm going to purposely pick certain one, just like the y-intercept. If you plug in 0 right here, that'll be negative 1 over 54. So I can just quickly say negative 1 over 54. Alright. So now, check it out, check it out, check it out. I'm going to graph this. 2x to the second power minus 10x minus 1 divided by parenthesis x squared plus 15x plus 54. Alright. Here's a little issue. When I graph this, remember I got 2 vertical asymptote, okay? Right there. And then I got another graph, probably on the left side here, outside. I'm gonna go to negative 20, so we can all see it. So by graphing by hand a little bit, you kind of know 2 vertical asymptote. The graph is actually divided up into 3 different parts. Okay, so I still don't see all of it. Okay, still don't see quite the whole thing. But what I can do is go to my table right now. See all these numbers? All right, make sure you get yourself a clean decimal. Identify the order pairs. So this one will be 0, negative 1 over 54. That's the first one I'm identified. All right, let's try another one. Okay. What was this one? This one was negative 4, 7.1. Negative 4, 7. Oh, I was about to type in decimal. You will not let me do that. So that means I gotta do fraction answers. If I cannot have integers for my answers, I gotta type in whole numbers. So that's the reason why you still need to be able to find these points by hand. Okay, so you gotta find these points by hand. That's why I show you how to do all this stuff. You know, picking a point to the left, to the right of vertical asymptote, and see what else we can find in between the two vertical asymptotes. Okay, you can just pick any point that you like. Okay. Now I'm not going to continue this problem because all you're gonna do is plug in the numbers and then figure out the fraction answers. I'm gonna actually go to another problem. Because there are other problems here where you got to actually graph. Find the equation of vertical asymptote. So I believe this vertical asymptote here will be x equals 5, x equals negative 5. If it's not, that means something canceled out with my 5 and negative 5. And I don't think so either, because this degree is higher than that. It's going to be wrong. Oh yeah. Okay. Separate. Find the equation of horizontal oblique asymptote. So this part is where we got to find the slant asymptote, where we got to do the long division. So that's not the one I want to show you. There you go. This is the one. Plot the vertical asymptote. How many vertical asymptotes do I have? It's just negative 5. If I set the denominator equal to 0, it's going to be negative 5. I'm going to say 1. And I'm going to click on at negative 5. Draw it for me. So this is the one I want to show you already. Alright, next step. Plot the horizontal asymptote. The degree, the numerator is 0, denominator is 1. So the numerator is smaller than the denominator. So there's one horizontal asymptote on the x-axis. So I just click on the x-axis. It draw it for me. And now, these are the things I was showing you how to choose. Okay, it's the same thing as what I did over here. So, in a way, if you really think about it, I can actually graph this whole function in the calculator. It will actually draw it for me. Okay, so these problems on the homework is kind of breaking it apart of what I just showed you how to do all this stuff by hand, in a way. Okay, I'm just not asking you to find me all 4 points. So if you just grab this in the calculator, you can actually sketch this. But I feel it's important for me to show you how to do this stuff by hand, how to sketch it by hand, so you understand what these things are here. All right, one vertical asymptote separating between 2 parts. The left side of the negative 5 is what? This one. Okay, we'll just drag it. The right side is going to be down this way, so I'm going to put it right there. Okay, and that's it. So these problems are kind of broken apart compared to these steps I'm showing you. Okay, all right, that's how we graph rational function by hand. Okay, thank you for